Hey everyone, welcome to another session of CeerazzleDazzlePhysics. In today's session, we're going to be talking about alpha, beta, and gamma radiation, guys. So put down today's title, it's going to be alpha, beta, and gamma radiation. Okay, let's get straight into it. Let's have a quick recap from our previous lesson before moving on. So previously, we talked about what happens when a nucleus becomes unstable. As you can see here, the nucleus has now become unstable. Maybe it's a bit too heavy. What's going to happen is the nucleus will break down. It will break down into two smaller pieces. There we go. That's one piece over there, another piece over there. Energy is also released. There we go. And you can also get alpha, beta, or gamma being released. You can get a combination of these or just one of them. So alpha, beta, and gamma can be released. These are forms of ionizing radiation, guys. So these are forms of ionizing radiation. And ionizing means it has an ability to rip off electrons from neighboring atoms. Right, so what exactly is alpha, beta, and gamma radiation? Well, they are the following. So we're going to scroll down now and we're going to define them right now. So here's my table. I've got name, symbol, made up of, and overall charge. So the first one we're going to talk about is alpha radiation. So alpha radiation, the symbol is going to be here. Wonderful. Yeah, for Greek symbol here. It's made up of two protons over here, and there are also two neutrons. Two protons plus two neutrons. And it is very similar to a helium nucleus. So I'll put that down in brackets, helium nucleus. Notice there are no electrons going around it, that's why it's just the helium nucleus. Right, the overall charge. Because I've got two protons and two neutrons, what will be the overall charge? Well, hopefully you can remember that protons have a charge of +1 and neutrons have a charge of 0. So I've got two protons, therefore it will be +2. The neutrons don't really count, so therefore the overall charge is +2 over here. So the overall charge is +2. So now we have done alpha radiation over here. Next one now. Next one is going to be beta radiation. So beta radiation over here. Our symbol is beta over here. It's made up of just a fast moving electron. So I'll draw a little electron over here, little green dot over here, and it's going to be fast moving electron by itself. Fast moving electron. The overall charge of it will be what? It's just a single electron, therefore you know electrons have a charge of -1, so the overall charge is -1 over here. And last of all, we have gamma, so we're going to put down gamma on this side over here. And what is it, guys? Well, hopefully you can remember from the previous topic, the waves chapter, it's an electromagnetic wave. So it's just an electromagnetic wave. So it's just an electromagnetic wave, and because it's an electromagnetic wave, there's no charge. So you can put non-applicable or no charge over here. So, or 0. I'm happy with that because the wave has no charge. So it has 0 charge over here. So make sure you're familiar with this before we move on. So make sure you know the name, symbol, what it's made up of, and the overall charge here. The overall charge. Okay, so now we're going to talk about now the penetrating ability of all three of them. So let's scroll down and learn a bit more. So scrolling down, here I've got a diagram, and as you can see I've got alpha, beta, and gamma radiation on the one side here, and I've put three materials in front of it. I've put paper, and then I've put thin metal sheets, and then I've put thick lead. Right, so if we were to fire all of them at each one of them, we will notice that the alpha, there we go, the alpha will travel across, but gets stopped at paper. So alpha cannot penetrate through paper. And a bit more information, it can also not be stopped by skin or 10 centimeters of air. So 10 centimeters of air will protect you from alpha. So your skin will protect you from alpha, and also paper or 10 centimeters of air. Beta radiation is a bit more penetrating, so it can actually pass through the paper, but it is stopped by thin metal sheets, like aluminium. So thin metal sheets will stop the beta radiation here. Gamma is the most penetrating, so therefore it can pass through the paper, through the metal sheets, but it's only stopped by thick lead. Notice it has to be thick lead. If you just have a small bit of lead, it will reduce it. So very thick lead will actually stop the gamma radiation. So we now know how to stop alpha, beta, and gamma, guys. Make sure that you're familiar with these as well. Right, so last of all is the ionization ability. I could just tell you, very quickly which one is the most ionizing, but I always like to explain it. If you don't want to hear it, then fine, just forward the video on. So alpha, we know it's got two protons and two neutrons. Beta, single electron, and gamma is just a wave here. Now imagine this is going to be like a box, and it's got loads of electrons. Each of these are electrons over here. These are electrons. I've just drawn the electrons over here. Right, let's say we were to fire alpha into it. We're going to fire alpha into it. So we're going to fire the alpha is going to enter this box over here. Ionization ability means its ability to rip electrons off. So its ability to remove electrons from atoms. So right now, if I was to fire the alpha particle into it right now, so we fire the alpha particle, because it has a charge of +2, bear in mind it has a charge of +2, it can rip off these electrons very easily. So this electron will be attracted towards it, yeah, and it moves towards it, and so will this one over here, and it's very ionizing. There we go, so it travels that far. So the alpha particle, it's very ionizing. Why? It's got such a large charge and size, it can ionize quite a lot. Notice it doesn't move that far because every time it ionizes, it loses energy. So it's losing energy right now. That's the reason why it doesn't go that far. Right, so beta radiation. Beta radiation, first of all, it can travel, but because it's so small and it has a low amount of charge, it can maybe attract this one over here and keep going, and then attract this one over here maybe, and then it's done. So as you can see, we know that it is less ionizing than the alpha. It is less ionizing than the alpha. And then gamma, last of all, gamma can travel all the way through, as it travels all the way through, and maybe interact with one of them, this one over here. Why? Because it's a wave, yeah? So the gamma can travel a bit further over here. So which one interacted with the most electrons? Which one was it? Which one interacted with the most? Right, so hopefully we can identify that alpha is the most ionizing. Look, it's the most ionizing. That's the reason why it didn't go that far. It's the most ionizing because it has the highest charge and highest mass. Then beta would say is the moderately, and then last of all, gamma is the least ionizing over here. Let's put that into a little box. Wonderful. As you can see, alpha is the most ionizing, beta is moderately ionizing, and gamma is the least ionizing, guys. So gamma is the least ionizing. Alright, so now scrolling down. Okay, so now we've actually done all of the theory for today. Here is a summary table for us to get our head around. So as you can see, we've got the names of the types of radiation, the symbols of them, and the composition, the charge, stopped by, penetrating ability, and ionization ability. Let's have a quick recap just to summarize what we've done today. Alpha, the symbol is the alpha symbol, made up of 2 protons and 2 neutrons. Charge is going to be +2. It's stopped by paper skin or 10 centimeters of air. The penetrating ability is low, and the ionization ability is high. Beta, the symbol is beta. Its composition is going to be a fast moving electron, and its charge is -1 because it's a single fast moving electron. Stopped by thin metal sheets. The penetrating ability is moderate, and the ionization ability is moderate as well. The last one is going to be gamma, and here's our symbol for gamma. It is not a particle, guys, it's a wave. It's just an electromagnetic wave. The charge is 0, or it has no charge. It's stopped by thick lead, guys, so it can pass through the paper and the thin metal sheet, but it's stopped by thick lead. And last one, we have the penetrating ability. It's going to be high. Ionization ability is going to be low in this case. Yep, and that's bringing us to the end of today's lesson. Let's have a quick recap right from the top. So right from the top, we said that alpha, beta, and gamma is today's title. And I reminded you guys that when the nucleus is unstable, it breaks down, releasing either alpha, beta, or gamma, or a combination of them all. Then we had our table. We talked about the symbols, what's made up of, and the overall charge. Then I did a diagram showing you the penetrating ability and what it is stopped by. Finally, I then talked about the ionization ability, and obviously it's kind of difficult, this bit, but you can just memorize the ionization ability if you want to. Most, moderately, and least. Alpha is the most ionizing. And last of all, here's our wonderful table summarizing everything that we have done today. Excellent. Right, so that's it for another session in CeerazzleDazzle Physics. Make sure you like and subscribe to get my channel going, and be like a alpha particle and stay positive. Goodbye.